Good morning. Today we'll go to the class 3 of the chapter Digital Electronics. As we have already studied a lot of conversions, and today we will learn about decimal to hexadecimal conversions. Now the conversions and all will be the similar to what we have already studied, so I am not going into much details. Here the only difference is you are going to convert a decimal number to hexadecimal. So hexadecimal means base is 16. So in hexadecimal number system, which all numbers you have? You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then instead of 10 in hexadecimal system you use the word A, capital letter A. Okay, so in for 10 it stands for A, and if it is 11 it will be B in hexadecimal system. If it is 12 it will be C. Then if it is 13 it will be D, and if it is 14 it will be E, and for 15 it will be F. So in your textbook there is a mistake. So in the notes that I have uploaded also you have to note this mistake. See, here instead of A they have written 11. It is not 11, it is 10. So this in before 10 there is a number, the before 11 you must write this number 10. Okay, then it will be correct. So instead of 10, 10 actually represents A in hexadecimal system. So A means 10. Okay, or 10 means A. Then for B, 11 it is B, for 12 it is C, for 13 it is D, and for 14 it is E, and for 15 it will be F. So here this 10 is missing in your textbook, so please do make that correction in your note that I have uploaded. Okay, textbook. So this is how actually you have studied that if you have given a number like this 62.45, this is your fractional part, and this is your integer part, and this is your fractional part. So in order to convert this into hexadecimal, first what you do is that you take the integer part first, and so to convert it into hexadecimal you divide it with 16, and for converting this fractional part into hexadecimal you multiply with 16, which we have already studied in earlier classes, in our earlier classes. So I am not repeating it again. The process will be the same as what you have done for decimal to octal, or all the other conversions. So let us straight away go to an example. Okay, this is here they are given only a integer alone. There is no fractional part, and here there is a, so here you are continuing multiplying with 60, dividing it with the 16, right? And then you get the reminders. And so here note that you are getting a remainder 11, but remember you are working with hexadecimal system, or you are asked to convert it to hexadecimal system. So you need to substitute this 11. Instead of writing 11 you have to write the corresponding letter, that is A actually stands for 10. So what will be 11 stands for B. So in your answer you have to write not 11, it will be B, and the answer is written in from bottom to top, which we have studied. Now this is the fractional part. You are given only fractional part, there is no integer part. So if you are asked to convert a fractional part into hexadecimal, instead of dividing with 16 you are multiplying with 16, and this process is continued until the fractional part becomes 0. So you stop there, and then here you are getting 10. So instead of 10 you will be writing A. Okay, and then the answer will be written from top to bottom, that is A8. Now this will be more clear if you are given these two together. See, look at this problem. Here you are given a number, and you are asked to convert it into hexadecimal. So hexadecimal, first of all you must understand you have to work with the base 60. So first you are having an integer part, that is 60, and what is a fractional part? 0.71875. So first of all work with the integer part. Now this integer part alone, that is 60 alone, you are converting into hexadecimal. So what will you do? First of all take the 16 and divide it with the 60. So 60 by 16, that is you are getting its remainder as 12. Why? 16 into 3 is actually what? 48. So there is a here it is 60. So 60 minus 48 is 12. So remainder is 12, but you cannot write it as 12. Write the equivalent number, letter, that is C. Then again you are dividing this 3 by 16. it will be 0. 0 into 16 is 0, so remainder will be 3. And what will be the hexadecimal equivalent of this integer 60? Right from bottom to top, it will be 3c. See, now next, the other part of the question, you are going to convert this fractional part into hexadecimal. So instead of dividing by 16, you are multiplying with 16. So you are multiplying, you get the number 11.5. This 11 is written here, and instead of 11 you are writing the equivalent letter, that is B, and 0.5 alone is taken, and again you are multiplying with 16, you get 8, and it is written here. Here fractional part becomes 0, so you stop multiplying, and so your answer will be from top to bottom, that is B8. Now on combining these two, you will get the final answer as this. Okay, now this the opposite, hexadecimal to decimal conversion, that is you are given a hexadecimal number. So if you are given a hexadecimal number, first of all write the number as such 436 and put the place value. If it is 436, it will be 0 1 2. So your hexadecimal equivalent will your decimal number will be 4 into 16 raised to this one 2 plus this 3 into 16 raised to 1 plus 6 into 16 raised to 0. On adding, you will get the answer as 1078. This is the one. This process and all you have already studied for other number systems. Everything is same, only the base that is changing. If it is octal, you will be working with 8. If it is hexadecimal, you will be working with 60. That's only difference. Now you are given two numbers combined, that is you have got an integer part and fractional part. So first of all, to convert, you are putting the place value. How will you put the place value in this case? 2 to 3.56. So starting from this decimal point, here you write 0 1 2, and for this numbers 56, you will put the place value as -1 -2. Then write individually. First of all, take this 2 into 16 raised to 2 plus this one 2 into 16 raised to 1 plus 3 into 16 raised to this 0. Then you put that dot as such, there is a decimal point. Now add all these things, you will get a number. Then after you put the dot here, and then the next number will be what? It will be 5 into 16 raised to this one -1. The other one will be plus 6 into 16 raised to -2. It is given here clearly. You can see what I have just written. And on adding, you will get the answer. So do remember, it will be separated by a dot. First of all, add all this. This will be 547. Then this dot as such. Then do the calculations of this one. This will be 0.3359375. Okay. On combining, you will get this answer. Next is binary equivalent to hexadecimal. Here also you have to study a table. In the last class, I have given a table like octal to binary conversions. Like similarly, here you have to by heart this table, hexadecimal to binary. As already said, there is a trick for studying this table. First of all, everything will be 0, and you keep the first two zeros as such. Then the last two digits you will change. That is first one 0 0 0 1 1 0 1 1. Then alone this 0 will change to 1. So 0 1 0 0. Later this 0 1 will be kept as such. Then change this 0 0 0 1 1 0 1 1. Then after that this 0 will also change. So 1 0 will remain the same for the next 4 digits, and the only change will be here, that is 0 0 0 1 1 0 1 1. Then in the last case 1 1 will be kept as such. See, 1 1 will be kept as such. The last change will be 0 0 0 1 1 0 1. So if you study this table, this is not there in your textbook. If you study this, don't by heart, try to by heart, just apply the trick that I have said, then it will be very easy for you to convert. Okay, hexadecimal to binary. You are given a hexadecimal number A35. To the base 16 means it's a hexadecimal number. Now you are converting it to binary. So A is nothing but 10. So what is A stands for? Look at the table. 1010, right? So you write this 1010 as such. Then what is 3? Look at the table, you will get this number, and by looking the table, the equivalent binary of this hexadecimal 5 will be 010. Now write all this together, it will give you the answer. Similar is the next problem, just work it out. Now just the reverse, binary to hexadecimal, that is you are given a binary number. So first you actually try to group it into a group of 4 bits. That is you are given the number 111010001. You are now grouping it into group of 4 bits. So this will be and this will be, so 2 groups. Now let's refer to the table. What does 1110 stands for? 1110 stands for E. So that E is written here, and the other one will be 9. Now write it together, will give you the answer. Now the last example, see, if you are given a question with separated by a dot, or there is a decimal point in between the integer part and fractional part, what will you do? Your grouping will start from the decimal point to the left first. That is, you are going like this, you are grouping like this into groups of 4 bits. So your first group will be 1101, then second group will be 0010, your third group will be 11 only, but you need a group of 4 bits. So how will you make that 11 into group of 4? You will add 2 zeros to the left, that is, we will just add 2 zeros to the left. So you will get the last one as 0011. Here they have written only 11, but it is actually 0011. Okay, now after that, do the grouping towards the right. So first of all, your first group towards right will be 1001. Then the next group will be 01. You are left with only 01. So how will you make it 4 bits? Now you are adding zeros to the right. See. Okay, now refer the table and write the corresponding equivalent number. So this will be 3, this is 2, and by looking at the table, this will be D, and write as such, and you will get the answer. So the conversions and all is similar to the other decimal other systems, number systems that we have studied. So please do the calculations and work out the problems. Okay, now in the next class we will learn about binary arithmetic. Now the conversions and all are over, so just go through all the conversions that you have studied till now, and remember, please make the correction. That is A in 10 in hexadecimal number system stands for A. That is this particular change that I have already told. There is an error. Okay, please do this correction. Okay, that's it for now. Thank you.